So hi everybody and welcome back to C++ tutorials for absolute beginners. This is video 355 and in this video we want to talk about converting constructor. Again, here in CPP reference comp you go to the language section, then here in classes you go here down to where it says converting constructor, and we will start from here. Okay, and the first thing what we are doing is reading here through. I'm not going to read this, I read only the first few sentences and describe them a little bit, and let's get started. First says here, a constructor that is not declared with a specifier explicit and which can be called with a single parameter until C++11. Later you can call it with more parameters, is called a converting constructor. And then it says here, unlike explicit constructors which are only considered during direct initialization, which includes explicit conversions such as static cast, converting constructors are also considered during copy initialization, a part of user-defined conversion sequence. Okay, and the most important part here is that one constructor has the word explicit and the other constructor, the converting constructor, is not using the word explicit. And now we are going down here to the examples, and here we see a struct A which has three different kind of constructors. We can see these are just constructors, and the one has no parameter, with parameter, and here we have two parameters, and here you can see this one was till, like it says, until C++11 with one parameter, and then after C++11 with no parameter or even with two parameters or more parameters. These are this one, and then we go here to the struct B, and here you can see here the word explicit is used. Again, we have here three constructors like here before. The only difference is really this word explicit, and like I said before, if you see the word explicit, then the converting constructor will not work. And how does this not work, we will see now here in the other examples below. Okay, let's get started. First of all, we have here this line, and it says here A is our struct A here on top. Okay, and then we create the object A1. Okay, and we are using here this one, and then you see here in the comments it says here, okay, copy initialization selects a int, which is our constructor here. It is the converting constructor with the old one. But the question is now why it is selecting that, because this looks not normal, because here on the right side we see just a 1 and we don't know which type this is. So let's watch this a little bit more in detail what happens. First of all, the compiler says I see here a number 1, I just interpret it as a number first, and then I choose what I can find here in struct A, and then the compiler checks here all the constructors, and then the compiler finds here a parameter. This is just then one parameter, and then the compiler says, okay, the one is for me int. And the next step is the compiler says I will now treat this one A1 for this constructor here. That's why it is called here the converting constructor. This one is chosen here, and you can think about this so that here invisible A is the type, this one here, and one is, and this one is then created and then copy here to this part. But of course there is again this copy elision, which means all the steps which I just mentioned you will not happen. It will internally solve more efficiently, and we can just assign 1 to A1. So let's repeat this one more time. What happens here? First we get a 1. This one goes here to the struct A, it checks all the constructors, it finds one with a parameter and with the type int which can be matched, and then the compiler says I'm taking this constructor. It constructs first on the right side a temporary object with the struct A, so we have here on the right side a A1. This one will be constructed, and whatever is here in the body will be executed as well. So if you write here, for example, an output, you should see later here an output, and then this kind of stuff will be, like it says here, copy initialized to A1. But the problem is, even if you write here something in, it could be skipped because this copy elision. But in the end, we are just creating with 1, this one here, this struct A, and then we just assigning to A1, which means if we have, let's say here an assignment and here a variable, it will be then assigned here. And to see this a little bit better, I have just copied the code here to the compiler explorer. You can use just your IDE, and then I have just uncommented all the other parts, and here I added here a cout to see when this parameter is called. You can see here in our first line here on the output, one parameter c2 was called, and this is exactly that what I wrote here. Okay, and when we compare now the other ones, they are similar. That's why we read them through and check this out. So let's start here with this line. It says here, direct initialization selects a int. Yes, we have here the number 2. Again, it checks all the constructors, the parameters. It finds this one, and then it selects the one with here, and it creates here this R2 object with the number 2. It is again called again with our first parameter theta was called. Then we have this one here. It is our direct list initialization. We see this with this curly braces, that's why. And we have here 2 parameters, and then you can see it is selecting this one here because like all time it checks the constructors. This has 2 ints, the number are matching again, and here it's printing nothing out because I have only wrote something here, but this works. Then let's go to the next line. Here we have a copy list initialization, again list initialization because we have here the curly braces, and it is a copy list initialization because we have here the equal sign, and again it checks here again and says yes, I can find here with the 2 parameters, so I take this. And then we have the last line, and like you can read here, it says here explicit cast performs static cast direct initialization. So remember, this cast here, this part here is a C style cast, which means we have first the one and then we define in which type we want cast in. But in C++ we normally not use this one, but you will see it a lot. But normally you should use, like it says here, the static cast. It's a little bit more readable and makes it more clear and makes not implicit conversions, and so it's safer. But in this case they demonstrate, of course you will see a lot of casts like this as well. And here you can see it's a direct initialization then. But the interesting part is this line. So it is an error, but let's watch first this part here. It says here B. Okay, this is our struct B, and in B you can see we have also the constructors just with the word explicit this time. And then we start again here again with the 1 like here before. It's similar to this. The only difference is here in the struct it has explicit, and this one has no explicit. This case we have an error. And when we read here now this description, it says here error copy initialization does not consider B and so in. So this one here looks similar to this one, but we have here the word explicit, and that's why it is not working. And this is the part which you have to learn when you use or see a code with the word explicit. That copy initialization is not working, and this is also here the description on top. It says here if you are using copy initialization and use the word explicit, it will not work. This is this example here. It is not working. And in the next line you see this one. This is similar to this line here, so you can see they are looking almost same. The only difference is the type here A, but this one here works. And again, this was here in the description. It says only copy initialization is not working, but direct initialization can work. And we can see here because this one here is a direct initialization. Direct initialization goes here and it works. And on the next line we have again a direct initialization, but this time we are using these curly braces. It is just called a direct list initialization. You can read this also here. But again, it is still a direct initialization, and that's why it is working like the rule here before, right? And then we go again to the next line and we have again an error, and the reason is very simple. When you see copy, it is again with this equal sign, is not allowed when you have this word explicit. So when you read here error copy list initialization, again you can see the curly braces means we have a list initialization, and this time not a direct because we have here the equal sign. It's a copy list initialization, selects an explicit constructor. This one it would normally select, but it is not allowed. The next line here is a little bit tricky because when we watch this one, we see here a cast. This is this part, and then we see a equal sign. We would normally think about copy, and then we see just the assignment. But when we read here the comment, it says here explicit cast performs. Okay, this is this part here. This is the explicit cast. Performs static cast. This is equivalent. This is just C style cast. Okay, so far so good. But it says direct initialization. What? We have here a cast and then an equal sign. Why is that a direct initialization? And that's why I said this line here is a little bit tricky, because normally you would see this equal sign. Yes, we make probably any copy initialization anyhow, but here actually what happens is, first we make this cast like it says here. Second, we have here indeed a copy. This part here till here is a copy initialization normally, but there is an invisible part, and the invisible part is there is this rule copy elision. We have talked about it. Copy elision means that the compiler can skip this part here if it's possible. And if this is possible, in this case it is possible, so the compiler will not use copy. The compiler will not create this temporary object here, which the cast would normally create. The compiler will instead skip this part here completely. Instead, it will just take this one and create it directly in B5, which means when you look this just syntax here, it looks like a copy, but the semantic, what the compiler is doing, is actually direct initialization. And this is the reason why this is working at all, because we have here again this word explicit. Again, here we have just one parameter, so it would choose this one here. It is working, because if this would be a copy, it will not work, because copy is not allowed with the word explicit. Okay, and then we go to the other parts here. We have here just a normal default initialization that's allowed. There is no copy. Then we have here a direct list initialization. Again, direct with just the curly braces is a list initialization. It's allowed. Perfect. And again, error, because we have here a copy list initialization. Again, here is the list initialization list, and we initialize it with this equal sign, which means here a copy. And this will try again, like it is showing here, it will try to use this one here, and this is not allowed with the word, very important, explicit. And that's why this is throwing error. And this kind of stuff we can skip. This is just a lambda which we have not learned. But important here is that you understand when you see the word explicit in this context with so in the constructors, then you have keep in mind there are these conversions like this one. You can write here 1, and the compiler is converting this 1 to this object here. It is just selecting this one, but it's only not working with the word explicit for copy initialization. Anything with copy, when you see here anything with copy, for example here the errors copy, and here copy, and here copy, and this one again is very hard to see. This is not a copy, but it looks like a copy. When you see something with copy initialization and the word explicit, it will not work automatically. This was everything for this video, and if you have any questions like all time, write in the comment section. See you on next video. Bye and good luck.